Greetings, cosmic travelers of the UNSS Phoenix XCS-337. Today we're venturing into one of the most perplexing mysteries of modern physics, the cosmological constant. But here's the twist. What if the cosmological constant is not constant? The cosmological constant is a term that Einstein introduced to his equations of general relativity to keep the universe static. Later, when it was discovered that the universe was expanding, Einstein supposedly called it his greatest blunder. But was it? Today, the cosmological constant is used to explain the universe's accelerating expansion, driven by what we call dark energy. But what if the thing causing the universe to expand faster and faster isn't a fixed value? What if the cosmological constant evolves? This opens up a Pandora's box of questions about the universe's ultimate fate, and about our understanding of reality itself. Prepare for an exhilarating ride as we explore this cosmic enigma with science, riddles, and a dash of humor. Let's blast off into the unknown. What is the cosmological constant? Let's start by understanding the basics. The cosmological constant, often denoted as L, lambda, was first introduced by Albert Einstein in 1917. When Einstein developed his theory of general relativity, he noticed something strange. Without a cosmological constant, his equations predicted that the universe should either expand or contract. But back then, everyone thought the universe was static, unchanging over time. To fix this, Einstein added L to his equations, representing an energy that counteracts gravity, allowing the universe to stay balanced and static. This mysterious energy is what we now call dark energy, responsible for the universe's accelerated expansion. In 1998, astronomers discovered that the universe wasn't just expanding, it was growing faster and faster, driven by this repulsive force known as dark energy. So the cosmological constant went from Einstein's blunder to one of the most essential elements in modern cosmology. But here's where it gets interesting. What if this value isn't constant at all? What if the cosmological constant, the very fabric of our universe, is not a fixed entity, but a dynamic force evolving and changing over time? Example: imagine you're driving a car on an endless highway, and suddenly you start accelerating. But instead of your foot on the gas controlling the speed, some unknown force is pushing the car faster and faster. You don't know what's causing it or how fast you'll end up going. That's the mystery of the cosmological constant. The cosmological constant problem, a crisis in physics. One of the biggest unsolved problems in modern physics is the cosmological constant problem. When physicists try to calculate the value of the cosmological constant based on what we know about quantum mechanics, they get an answer that's 120 orders of magnitude larger than what we observe. This is the most significant discrepancy between theory and observation in the history of science. The cosmological constant we measure is tiny, but according to quantum field theory, the energy density of space, the vacuum energy, should be enormous. So why is the actual value so tiny? Could it be that the cosmological constant isn't constant, but changes over time? This leads us to ask whether L might be a dynamic quantity rather than a fixed value. If the cosmological constant is changing, what's causing it to change? Is it linked to new physics beyond what we currently understand? Example: it's like if you ordered a pizza expecting a huge one, but when it arrives, it's a tiny slice. Something doesn't add up, and you're left wondering what happened to the rest of it. Could the cosmological constant vary over time? Now we dive into the heart of today's topic. What if L isn't constant? Some theories suggest that the cosmological constant might change over time. One of the leading ideas is that dark energy isn't constant, but rather a form of energy that evolves as the universe expands. In this case, the cosmological constant could be a temporary state of this changing energy field. One hypothesis is the quintessence model. In this theory, dark energy isn't a constant force, but is produced by a dynamic field that changes over time. This field could be slowly decaying, meaning that the universe's expansion rate isn't fixed. It might speed up but eventually slow down or even reverse. If the cosmological constant decreases over time, the universe's fate could be very different from what we currently imagine. Instead of expanding forever, it might reach a point where dark energy weakens, and gravity takes over, pulling everything back together in a big crunch. On the other hand, if L increases, the expansion could accelerate so much that the universe could end in a big rip, where galaxies, stars, planets, and even atoms are torn apart by the ever-accelerating expansion of space. The implications of these possibilities are mind-boggling and will keep us pondering about the fate of our universe. Interesting fact: scientists are currently conducting experiments to determine whether the cosmological constant is truly constant or if it shows signs of varying over time. One such experiment is the Euclid Space Telescope, launched by the European Space Agency, which will map the geometry of the universe with incredible precision to look for clues about dark energy and the cosmological constant. Riddle: I expand and accelerate, but what drives my pace? I change with the stars and yet leave no trace. What am I? The fate of the universe. If L changes, so what happens if the cosmological constant is not constant? Let's explore the different potential fates of the universe depending on whether L increases or decreases over time. Scenario 1. The Big Rip. If the cosmological constant increases over time, the universe's expansion could accelerate to the point where everything is torn apart. Literally, galaxies would drift away from each other at faster than light speeds. Stars would break apart. Planets would be torn from their orbits, and eventually, even atoms would be ripped apart. This is the terrifying scenario known as the Big Rip. In this case, dark energy would eventually overwhelm all the forces holding the universe together, and the cosmos would disintegrate into a chaotic soup of particles. Scientists estimate that if the Big Rip is our fate, it could happen in about 22 billion years. Scenario 2. The Big Crunch. Conversely, if the cosmological constant weakens over time, gravity could eventually win the cosmic tug-of-war, causing the universe to slow its expansion and start contracting. The universe would collapse in this scenario, leading to a big crunch. All matter, space, and time would reverse, shrinking into an incredibly dense state, possibly even back into a singularity, setting the stage for a new Big Bang. Scenario 3. The Cosmic Balance. There's also the possibility of a perfect balance, where the cosmological constant and the forces of gravity reach a stable equilibrium. In this scenario, the universe would expand forever, but at a decreasing rate, approaching a steady state where galaxies drift apart slowly, but without dramatic cosmic destruction. This is sometimes called the Big Freeze or heat death, where the universe continues expanding until it becomes cold and dark, with all stars eventually burning out. Example: think of the universe like a rubber band being stretched. It might snap if you keep stretching it too fast, Big Rip. But if you let go, it might collapse back together, Big Crunch. And if you stretch it just right, it might stay at a perfect length, Cosmic Balance. Joke: why don't scientists trust dark energy? Because it's always pushing things too far. Did you know that a changing cosmological constant could also solve other mysteries, like why the universe's expansion rate seems different when we look at various points in time? Some scientists believe that a dynamic cosmological constant might help resolve this so-called Hubble tension, one of the most giant puzzles in cosmology today. Now it's your turn to join the conversation. What do you think the cosmological constant is? Could it be changing over time? If so, what do you think the universe's ultimate fate will be? Big Rip, Big Crunch, or something else entirely? Let us know your thoughts in the comments below, and don't forget to vote in our poll. What do you think will happen to the universe in the far future? As we wrap up today's dive into the cosmological constant, prepare for our next adventure into one of modern science's strangest and most mind-bending concepts: the holographic principle. Could the entire universe be a two-dimensional hologram, with all the information about the 3D world encoded on a distant surface? Find out in our next episode as we explore this mind-blowing idea. We hope today's journey into the mysteries of the cosmological constant has expanded your mind. Whether it's constant, changing, or something we don't yet understand, this tiny term in Einstein's equations holds the key to the universe's ultimate fate. If you enjoyed this cosmic exploration, subscribe to Crazy Franks' Crazy Video Productions on YouTube. Don't forget to hit the bell icon so you never miss an episode. For more cosmic content, check out Being Frank with Crazy Frank, where we explore space, science, and beyond. Answers to riddles. Answer: dark energy, the ever-changing force driving the expansion. Answer: time, it accelerates and yet remains elusive. Answer: the cosmological constant, its role in the fate of the universe.
And thanks for watching.